let's talk about the most complex object in the known universe. Turns out it's right between your ears. Scientists are now building a map of its wiring, and what they're discovering might just change everything we think we know about who we are.
So let me just start with this one big idea. Just think about it for a second. What if everything that makes you, you, all your memories, your quirks, your entire personality, what if all of it is just the specific way your brain is wired together?
Now, before we can even begin to answer that, we have to appreciate the enormous puzzle that scientists have been staring at for centuries, the unbelievable, mind-boggling complexity of the human brain.
And that's not me exaggerating. For neuroscientists like Jeff Littman, looking at the brain's physical wiring is, well, humbling. He actually calls it depressingly complex. It's this dense, tangled-up web that has just defied any simple explanation for hundreds of years.
You want to put some numbers on that complexity? Okay, get this. Your brain has about 100 billion neurons. But that's not even the craziest part. Those neurons form trillions of connections, or synapses. The scale is so massive, it's kind of hard to even wrap your head around.
And right there, that's the core of the scientific problem. For so long, we've been trying to figure out things like schizophrenia, or even just how we form a memory, without a complete wiring diagram. It's like trying to fix a computer without knowing how the circuits are laid out. It's been a huge roadblock.
So this massive challenge gave birth to a goal just as ambitious as, say, the Human Genome Project. The mission was to finally create that complete map, and it has a name, the connectome. It's the total wiring diagram of a brain.
So, okay, you have this incredibly ambitious goal, but how on earth do you even start to map something so vast? Well, you launch one of the biggest scientific projects in recent history, the Human Connectome Project.
The whole thing kicked off in 2009. The National Institutes of Health started the Human Connectome Project, or HCP, and it had one really audacious goal: to build the very first comprehensive network map of the human brain.
And the goals were super clear. First, they needed to map the connections in hundreds of healthy adults to create a normal baseline. This would finally give science a reference point to understand what might be different in the wiring of brains affected by disorders like autism or Alzheimer's.
So here's how they did it. They scanned 1,200 healthy adults, and they were mapping two different things. First, the physical wiring itself, the structural connections. You can think of this like a road map. But second, they recorded the brain's real-time electrical activity, the functional connections. This is more like tracking the actual traffic flowing on those roads.
And you know, once all the data from those scans started coming in, it revealed something completely unexpected. A really surprising twist in the story of the brain's physical roads and the actual conversations happening inside our heads.
The big surprise was this. What the brain is doing doesn't strictly follow the path of its physical wires. There was this pretty stunning disconnect between the brain's structure and what it was actually, up to.
Okay, so this paradox is really the key. The brain's structural connectivity, its physical highway system, is actually kind of sparse. It's limited. But its functional connectivity, the patterns of brain activity, that's a completely different story. It's a dense, fully connected web. Brain regions were talking to each other all the time, even without a direct physical road between them.
So somehow, different parts of the brain were having these intense, coordinated conversations, even without a direct physical highway connecting them. The brain's activity, its function, literally transcends its own physical structure.
It's kind of like this. Imagine the physical wiring is the highway system. But our actual thoughts? They're more like phone calls. They can instantly connect any 2 points, any 2 cities, regardless of whether there's a direct road. Our mental life isn't limited by the physical map.
This is a pretty mind-bending result, right? And it has these profound implications for how we understand ourselves. It's led to a really simple but powerful new idea about the physical basis of our identity.
MIT neuroscientist Sebastian Singh basically crystallized this whole idea into 4 simple words. He argues that this intricate map, this pattern of connections, isn't just a part of you. He says it is you.
The meaning behind that is just staggering. Every memory you have, every skill you've ever learned, the very essence of your personality, it's all encoded in the unique pattern of your brain's wiring. The reason we're all unique individuals is because no 2 connectomes are exactly alike.
To help us wrap our minds around this, Seung has a beautiful metaphor. He says, your connectome is like the stable, slow-changing stream bed of a river. That's your core self. And your daily thoughts, your feelings, all your perceptions, that's the water, constantly flowing through it.
And this is the most hopeful and mind-bending part of the whole metaphor, the water also changes the streambed. This means your experiences, every new idea, every learned skill, every significant memory, they are physically rewiring your brain, slowly altering the very map of who you are.
So this whole journey into the brain's wiring brings us right back to where we started, to that big question about identity. But now it's with a much deeper, more provocative insight.
And that leaves us with this final, really mind-bending question to think about. If your connectome is you, but it's constantly being reshaped by your life, how much of you is truly fixed? It suggests that maybe our identity isn't a static thing at all, but a dynamic, ever-evolving masterpiece. It's something to think about.